Hello and welcome to the final paper from June and May 2018. So it's a third paper, calculator again, from this series. So some of the questions here are pretty nasty, but I'll do my best to explain them. As ever, have your calculator and a good one and know it well. That's my absolute best advice, as well as never ever leave a question blank. The only way to guarantee getting 0 marks is to put nothing at all. Let's have a look then, starting from question 1, of course. Question 1 kicks off fairly gently, as normally all the time. We've got a scatter graph here, which shows for information about 12 girls. It shows the age of each girl and the best time she takes to run 100 meters. Write down the type of correlation. Now, even though this question doesn't ask you to draw in a line of best fit, you should do this as almost a knee-jerk reaction. If you see a scatter graph, be thinking at some point, sooner rather than later, ideally, draw in a line of best fit. So here's mine for this one. Always keep it as well within the range of points. For example, there's no points plotted down here, so don't carry it on forever. Don't carry it on from down here either, because we don't know any points up here. So keep it within the range of values. So write down the type of correlation. Only 2 types, only positive or negative. This line of best fit is going downhill as you go from left to right, therefore this correlation is simply put negative. Next, it says Christina is 11 years old. Her best time to run 100 meters is 12 seconds. She's damn fast for an 11-year-old. She's fast for anyone of any age. The point representing this information would be an outlier. Explain why. Well, let's just think about where 11 years old and 12 seconds, where'd that look? So 11 years old, 12 seconds is here. That's an outlier because it doesn't lie anywhere close to the pattern. It's a mile away from the line of best fit. So you need to explain to the examiner something on the lines of it does not fit with the established trend, or I'd say, put it even simpler, her data point is very far away from the line of best fit. Finally, we're told about Debbie. She's 15. It says a scattergram shows I should take less than 12 seconds to run 100 meters. Comment on what Debbie says. Well, 15 is here, and there's no data for 15-year-olds. We can't draw this line of best fit and extend it forever. Otherwise, we'd have like 20-year-olds be expecting to run 6 seconds for the 100 meters. So it's only valid for a certain range. So 15 is outside of the range of validity because we have no data for 15-year-olds. Put simply, I'd consider saying something like this. We can't say for definite what Debbie should or should not be running because 15 is outside of a range of used ages. The oldest person here was 13 years and maybe 8 months, look. No one was 14 years or older. Question 2. Expand and simplify. 5 brackets p plus 3 minus 2 lots of 1 minus 2p. So do the first bracket first. 5 times p is 5p. 5 times 3 is 15. Now this 2 is a negative 2. Okay, so just remember this is a minus 2 I'm using. Minus 2 times 1, if in doubt use your calculator. Minus 2 times 1 is minus 2. Minus 2 times minus 2 is plus 4. So minus 2 times minus 2p is plus 4p. Now we've expanded, we need to simplify. So we've got 4p here, sorry 5p there, plus another 4p here. So 5p plus 4p gives 9p, and 15 minus 2, start with the positives first, think of the negatives of what you're subtracting from that. 15 take away 2 still leaves us with 13. So we have 9p plus 13. Question 3. We have a trapezium drawn on a centimetre grid. On the grid, draw a triangle equal in area to this trapezium. How do you work out the area of trapezium, I wonder? Well, it's a formula you should know and be familiar with, ideally, and it's this. Area of trapezium is half times a plus b multiplied by the height, where a and b are the 2 parallel sides. So a could be that one, and the other one, b, is that one. So in any order, A and B are the two sides of the trapezium which are parallel. So for this one, it's half of, well, A is 2 squares long. This one's 1, 2, 3, 4, 5, 6, that's 7 squares long. And times it by the height, well, the height of this one, let's just see now, from top to bottom, it's 4 high. So I'm going to times that by 4. So a half of 2 plus 7 times by 4, that gives us 18. 18 units squared. So all we need to do now is to draw any triangle you can that has an area of 18 square units. I'm going to show you two possible triangles. There are others as well you could have drawn. So one triangle is this one. Remember, triangle area is base times height divided by 2. So that's 6 along, 6 high. 6 times 6 is 36. Divided by 2 gives us 18. That one would work. Or you could have something like this if you wanted. That's 4 along and 1, 2, 3, 4, 5, 6, 7, 8, 9 high. 4 times 9 is 36. Half it because it's triangle. Again gives you 18. So as long as you draw a correct triangle with an area of 18, you're good. Question 4. We've got a biased 6-sided dice which is thrown once, and the probability of it will land on a 4 is 0.65. This dice is thrown twice. Amir draws this probability tree diagram and it's not correct. So we need to spot two things that are wrong with a probability tree diagram and explain this to the examiner. So, step by step. Look at these two numbers here. Each time a tree diagram branches from the same point, all of the probabilities for that emanating from that point need to add up to 1. 0.65 plus 0.25 adds up to 0.9 when it should add up to 1. So that's the first error. So first mistake, the first branch should add up to 1. In other words, the probability of it not being a 4 should be 0.35. So you could say one thing or the other, but that's essentially saying the same point twice. So either say these add up to 1, or you could say instead of 0.25, it should be 0.35. Next, we're told clearly the probability that it lands on a 4 is 0.65. So that's right, but look over here. For the second row, that says 0.35 instead of 0.65. So these two here are in the wrong order. These need to be switched over. That's 0.35, should be 0.65 like I've said. So these need to do a little switcheroo. So the second thing you could say is something along the lines of the probabilities for the top two branches for the second row are the wrong way round. So 1 mark for each of those valid points. Question 5. ABC is a right-angled triangle. Work out the size of angle ABC. So angle ABC is that one which has been drawn here. Give it correct to 1 decimal place. So it's a right-angled triangle, so it's going to be a case of SOHCAHTOA. So we're going to use SOHCAHTOA this time. Now let's label on the angles and sides we know. So opposite to the angle we're trying to find is called the opposite. We don't know that one. The longest side, the side opposite to the right angle, is called the hypotenuse. We do know that one, so let's go for a triangle that uses this information. So any triangle here with a H, let's tick it. The other side, if it's not O or H, is A for adjacent, and we also know the adjacent side, so I can tick that, and let's tick as well where we can see an A. We use a triangle that uses the most information. So the one we're going to go for here is CA, which has 2 ticks, which is more than just for 1 tick each for the other ones. Now we're trying to find an angle. We know A, we know H, so we're trying to find this C. But if you're ever finding an angle, this C stands for cos minus 1 of A over H. So ABC will equal this. So ABC is cos minus 1 A over H. So A is 7, H is 11. 7 divided by 11, cos minus 1 of that. Let's see what we get. So shift cos minus 1, 7 over 11. We get 50.5 degrees, correct to 1 decimal place. Next, it says the length of side AB is reduced by 1 centimetre. BC is still the same, angle ACB is still 90. Will the value of cos ABC increase or decrease? You must give a reason. So before it changes, so the original value, C for cos of this angle ABC is the adjacent over hypotenuse. So it used to be 7 over 11, which if you want to, we can work out as a rough decimal. Bear in mind, cos of an angle is different to the angle itself. Okay, so don't be thinking, no, but I thought the angle was 50.5. It was. The angle is 50.5, and the cosine function of that thing is equal to 711. So cos of an angle is completely separate in terms of meaning to the angle itself. Now this one here gives me 0.63 with dots on the heads, which means 0.63 recurring. Whereas now, after these changes, cos ABC, the side of 7 is still 7, so 7 stays put. But now the hypotenuse here, 11, it says is reduced by 1. So the 11 minus 1 becomes 10. So it's become 0.7. So it's gone from 0.63 recurring to 0.7. In terms of money, that's about 64p. This is about 70p. So it's actually increased. So therefore, cos ABC has increased. In terms of giving reasons for your answer, you've shown it here by working out the original and the new. Number 6, a standard question really, always about counters in a bag. There's some counters in a bag for either red, white, blue or yellow. Bob is going to take at random a counter from the bag, and the table shows each of the probabilities that the counter will be blue or will be yellow. There are 18 blue counters in the bag. The probability that the counter Bob takes will be red is twice the probability that the counter will be white. So if I just take this in terms of probability of it being white, if I call that X, say, the chance of him picking a red is twice that probability. So I'm going to go red is double X, which is 2X. Next, it's about the blue counters. There's 18 blue counters in the bag. And the chance of picking a blue is 0.45. So 0.45 is the same as 45%. So therefore, 18 counters is 45% of the total counters. Next, we can work out what 100% is. So I can go from 45% to 1% by dividing by 45. And I need to divide this side by 45 as well. So 18 divided by 45 gives me 2/5, which is 0.4. Now times by 100. Naught 0.4 times 100 is 40. So therefore, there must be 40 counters in total. So we're going to use that to help us answer the question. So going back to the probabilities now. 0.45 chance of blue, 0.25 being yellow. So these here, for red plus for white, must be the other 0.30. So 2x plus x equals 0.30. In other words, 3x is 0.3, so therefore x equals 0.1. So therefore, probability of red equals 2x, which is 0.2. So in other words, 20% of the counters are red. So therefore, number of red counters must be 20%. And 20% comes from the fact that the probability of being red is 0.2. So it's going to be 20% of the 40 in total. And 20% of 40 is 8. So we've got 8 red counters. Now part B is slightly awkward to explain. A marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. There must be an even number of marbles in the box. Explain why. Well, if I'm taking a marble and the chance it's silver is 0.5, 0.5 is exactly half. So that's saying half of them must be silver and half must be not silver. So the marbles must also, of course, be a whole number of things. And so if half of a whole number of things are silver and half are not, then the total must be divisible by 2, because I've got half which are silver in one pile and half which are not silver on another. And if I can take a number and divide it by 2, an odd number doesn't divide by 2, only an even number is divisible by 2. So in terms of an explanation, something like this might do you just fine. There has to be a whole number of silver marbles, and 0.5 is 1/2, which means half of the total marbles must be a whole number. Only an even number, when it's halved, gives you a whole number, so there has to be an even number of marbles in total in this box. Question 7, I have an equation to solve. So I've got 5 minus x over 2 equals 2x minus 7. The first thing I'd suggest to do would be to double both sides of this equation to get rid of any fraction. So if I double the left, 5 minus x halved, then doubled again, will just give me 5 minus x. And to keep it balanced, I need to double the other side. So double 2x gives me 4x, and double minus 7 gives me minus 14. To solve equations with unknowns on both sides, I need to have all the unknowns together on the same side of the equation. So what I need to do here is I need to add an x to both sides. You always move the smallest number of letters across. You always change the smallest number. So minus 1x is smaller than 4. So focus on this one. So if I add an x to both sides, then we'll just be left with 5 on this side. 4x plus an x gives me 5x, then minus 14. it looks like, as I sometimes say to students, you need to be careful of the method though. It looks like this minus has switched sides to join there. It's swapped side, it's swapped sign. 4x plus the x gives 5x. The objective is to have x on its own. So here this minus 14 is in the way. I could add 14 to both sides to undo that minus 14. So on the left, 5 plus 14 gives me 19. On the right, 5x minus 14 plus 14 cancels to just give me 5x. And again, it's seeming like that minus 14 has swapped side and swapped sign become a plus. 5 plus 14 is 19. The final step now, to get from 5x just down to 1x, is to divide both sides by 5. And when we do that, we'll see that therefore x is 19 over 5. And if you want to write it as a fraction, your calculator can do that if you want to write it as a decimal, I mean to say, your calculator can do that for you. Just press 19 over 5, press equals, and then the S arrow D button will give you 3.8. So either method, either way of writing it down is absolutely fine. But x equals 19 over 5 or 3.8, either or. Question 8. We've got a pentagon here, and we're talking about angles inside a pentagon. So angle BCD is double angle ABC. We need to work out the size of angle BCD, showing all steps in our working. Now, we need to work out for this what the total of all the angles in a pentagon add up to. So we need to remember how to do that. There's two main ways of doing it. So the sum of the interior angles of a pentagon. There is a formula for it, and here's a formula for calculating the sum of the internal angles for any polygon. Your first method, use the formula. The total of the interior angles is 180 times by the number of sides minus 2. So for a pentagon, number of sides is 5, n minus 2 is 5 minus 2, which is 3. 180 times 3 gives 540. That's one way we could do it. I'm now going to assume that you didn't know that formula, or maybe you knew it, but you forgot it. A very versatile method you can use is to consider any polygon as a number of triangles just glued together. So the second method is to split the shape into individual triangles. You can do this as you want, but do remember what I'd say is have your triangles coming from the same point. So I'm going to do triangles coming from E. I'm going to do a line down from E to C, then a line across from E to B, to split it into 3 triangles like this. It's got one triangle, a second one, and a third one. So you can think of a pentagon as 3 triangles glued together. As long as you can remember that the angles inside a triangle add up to 180, like so, it's not so hard to imagine that we've got 3 lots of 180, which totals 540. So that's another way of doing it. Whichever way into the question, you need to have that as a starting point, that the sum of all these angles adds up to 540. I'm now going to clear this so we can focus on the diagram itself. So just remember that the total's 540. Goodbye. Okay, so let's label on this information. So angle BCD is the angle at C, this one down here. We're told that that's double whatever the angle ABC is. So angle ABC is this one here. Always go for the middle letter. So C, C, middle letter here, B, it means the angle at B. So all we're saying here is the yellow angle I've coloured in is double the size of the green angle. But I don't know what either are. So what I'd suggest is, call the smaller angle, angle ABC, X. Angle BCD is 2 times that. In other words, BCD is double this one. If I've called this X, this will be 2 times X, which is 2X. So what I said from before, the total of all the angles adds up to 540. Now, this is obviously a right angle, so if you're wondering where this 90 degrees comes from in my calculation, I'll explain that in a moment. So now we can form the equation. So all of these 5 angles need to add up to 540. So 115 plus 125 plus this angle x plus this angle here 2x plus 90, which I'll explain is because of this one here. That needs to add up to 540. So that 90 comes from that right angle there. 2x, because that's what I called BCD, and I called ABCX. So now what I can do is I can simplify this down somewhat. So 115 plus 125 gives me 330. Sorry, 115 plus 125 plus 90, I mean to say. So that adds up to 330, all these values. That plus that plus that gives 330. X plus 2x gives a total of 3 x's. And that equals, like we said, 540. So now we've got an equation to solve to work out what x is. So what I'd suggest we do here is take away 330 from both sides. So we've just got x on its own. So take 330 from both sides of the equation. That tells me that 3x is 540 minus 330. That leaves us with 210. Finally, to go from 3x down to just 1x, I could divide both sides of this by 3. So that becomes x, and 210 divided by 3 gives 70. Be careful, that's not the final answer. X is 70, so that's saying that we've worked out this one, which is 70. So angle ABC is 70. We want to work out, though, angle BCD, which is 2x. So we need to double our value of x. So therefore, angle BCD is one we're trying to find. Angle BCD is 2 times 70, which is 140 degrees. And that's that one done. Question 9. We've got t is a square root of w over d cubed, where w equals 5.6 times 10 to the minus 5, and d is 1.4 multiplied by 10 to the negative 4. Now, it's saying here to work out the value of t, and give your answer in standard form correct to 3 significant figures. Well, I've got a brilliant way of doing this on a calculator. I'll show you how to do it without first, just so you're not overly reliant on button bashing and not understanding. What we do here is we just simply substitute in the values. So t is the square root of w. Now we're told w is 5.6 times 10 to the minus 5. So put it on the top, within the square root. Now this is where people will often make a mistake. I'm doing d cubed, so d is this, and it's cubed. So what I'm going to suggest we do here, in fact what I'm telling you to do, is you put d in brackets so that you're cubing the whole of d, not just the 10 to the minus 4 part. So it's this thing here, all cubed. So if you type it in carefully, just as I'm showing you, your answer will drop out correctly, and I'll show you how to type it in exactly. There's 2 methods how to type in standard form on most modern calculators. I tend to do it the manual way. So if you press square root, then fraction to get your fraction button up, 5.6 multiplied by 10, press the power button, minus 5, toggle down, open bracket, 1.4 times 10 to the power minus 4, close bracket, and then cube all of that, I get 4715.539 and so on. So I've got 4517, then it was 0.539 and so on and so on. I want this in standard form. I'll show you how to do it manually, then I'll show you how to do it on the calculator. So in standard form, I need the decimal to be behind the first significant figure. So I want the decimal to be here. So it needs to be in the form 4.517 times 10 to a certain power. Now the power of 10 I need is the difference between where the decimal is and where the decimal needs to be. It's how many digits are in between where the decimal is and where it needs to be. So as you can see here, I've got 1, 2, 3 digits in between, and 4,500 and odd is a big number, so it's going to be a positive power of 3, so it's going to be times 10 cubed. However, we need to give this to 3 significant figures, so I'm wanting to keep 1, 2, 3 of these values. So it's either going to be 4.51 or 4.52. Because that 1 is next to a 7, that 1's going to round up to a 2. So to 3 significant figures, I get 4.52 times 10 cubed. So I did say I'd show you how to do it on a calculator. So here we go. So we'd type in exactly the same way as what we have done. That's no different. What we would do though to get it in standard form is we press Shift menu, and you should have an option for number format. You'll have a similar one on your calculator if it's a different model. I'm just showing you this one, which is a very common GCSE model now. So number 3, number format. Standard form is a scientific type of number format. So we press 2 for Psi. That's essentially stands for standard form. Just think S for standard form. So press 2. That says 0 to 9. That tells you how many significant figures you want your calculator to give the answer to. So in our case, we wanted it to 3 significant figures, so press 3. Nothing's changed, you might think, but if you press equals again, just like magic, you're given the answer exactly as you need. 4.52 times 10 cubed. By the way, if then you're doing another calculation and you're thinking, oh, it's stuck in this weird mode, don't panic. We just press Shift menu, go back to number format. We want it back into normal mode, press 3 for normal. And for some reason, I prefer normal mode too. So that's how you go back into normal mode. Press equals again, it goes back to normal. Now, part B. It says W is increased by 10%, as is D, but D is increased by 5%. The value of T will increase because both W and D are increased. She's wrong, explain why. I think the easiest thing to do here is just to do the calculation of the new values of W and D. So the new value of W will be 5.6 times 10 to the minus 5, essentially what it used to be. But an increase of 10% just means I'm going to add on an extra 10% to the 100% it used to be. So I'm going to multiply by 110%. Remember, we always start off with 100%. If we add 10%, that means it becomes 110% of its previous value. Alternatively, as a decimal multiplier, we could just multiply by 1.10, 1.1 essentially. So if we try this now, so the new value of W, 5.6 times 10 to the power minus 5, times that by 110, shift %. We get this. So we get that the new value, this might seem a bit strange here, I've got 3 different figures, so I can leave it as it is, to be fair. So I've got 0.0000 616. Just double check I've got that right. Yes. Then do D new. So d new has been increased by 5%. So I'm going to add on an extra 5% to its original 100%. It used to be 1.4 times 10 to the minus 4. If I now multiply that by 105% of its original self, I'll get the new value for d. So 1.4 times 10 to the power minus 4 times 105 shift percent. Press equals, I get 0.000147. So therefore, the new value of t, it's going to be the new value of w, which is 0.0000616, divided by the new value of d cubed. So we're going to divide by 0.000147, and do remember to cube it. So if we try this, and see what we get, 0.0000, one too many zeros, whoops, 616, all divided by 147 cubed, I get 4,403.66 roughly. That's actually smaller than the original value of t. That's smaller than 4517.539, which was the original value of t. So that shows quite comprehensively that Lottie's wrong. The value of t actually decreases, not increases. It's less than what it was before. So therefore, just say Lottie is wrong. It actually decreases, not increases. Question 10, we've got three different lamp bulbs, A, B and C. Lamp A is flashing every 20 seconds, B every 45 and C every 120. They start flashing together at the same time. How many times in 1 hour will the three lamps flash at the same time? So a key thing to spot here is lamp A and lamp C. 20 is a factor of 120. So what this means is lamp A will always flash when lamp C flashes. So when lamp C goes off, that'll always coincide when lamp A flashes. Lamp A will be flashing more, but C's flashes will always go hand in hand with lamp A's. So I'll just write this up because it's pretty important. Because 20 is a factor of 120, lamp C will always flash at the same time as lamp A. If you think about the 20 times table, we've got 20, 40, it'll flash again in 60 seconds, in 80 seconds, 100 seconds, and 120 seconds. Obviously they flash at the start, 0 seconds, whereas lamp C, 0, 120, 240, so they'll always flash together. If I carried this on for another 6 numbers, I'd get 240. So I don't really need to worry about lamp A, to be honest. All I need to do here is just consider multiples of 45 and multiples of 120. So just consider lamp B and lamp C. So multiples of 45. I'll show you how to do this quick on the calculator if you'd like. So all I need to do is 45 plus 45. I know you know that's 90. So 45, 90. But then what you do is press plus 45 again. Then just keep pressing equals. 135, 180, 225, 270, and so on. So you can always double check with your calculator. Then you get 315, 360, and so on, and so on, and so on. Whereas multiples of 120, 120, 240, 360, 480, and so on and so on. But hopefully you've spotted already that there's a number that's appeared already in each list, which is 360. So therefore, the lowest common multiple of 20, of 45, and of 120 equals 360. So that's 360 seconds. So what that means is, therefore, A, B and C, they flash together every 360 seconds. Now 360 seconds just happens to be exactly 6 minutes. So in 1 hour, well, 1 hour's 60 minutes. So if we flash once together every 6 minutes, if I multiply by 10, so they flash together 10 times. Every 60 minutes, in other words, every hour. Just shows how wonky my writing is. Interestingly, you'd get a mark for saying reasoning 11 as well if you wanted. If you reasoned 11, you get a mark because they flash together when the time is 0. So they flash on 0 minutes, 6, 12, 18, 24, 30. So if you consider flashing at 0 and at 60 minutes exactly, you could reason 11 times. But I think the best answer here is to build up. They flash once every 60 minutes. That's 10 times every hour. Question 11 is very back to front. So in 2003, Jerry bought a house. 2007, he sells it on to Mia. He then makes a profit. He makes money, so he must have sold it for more than he bought it for. In 2012, Mia sold the house for £162,000. She made a loss of 10%, so she must have sold it for less money than what she bought it for. So what we need to do for this one is we work backwards in time to work out what Joe paid for it back in 2003. So in 2012, £162,000, because that's a loss of 10%, that equals, therefore, only 90% of what Mia paid for it. So she's lost 10% on it. So £162,000 equals 90% of what Mia paid. Remember, before anything happens to an amount, you always start with 100% of its original self. So if it's a 10% loss, that's 90% of the original. So obviously she paid more than £162,000 for it. So now what we can do is we can build to find out what 100% was, what she paid. Wrong line. So what I'm going to suggest we do here is divide by 90 to find what 1% was. So 162,000 divided by 90 gives 1,800. So £1,800 is 1% of what Mia paid. And to go from 1% to 100, we can simply just multiply by 100. So therefore, Mia must have paid £180,000 for her house. So £180,000 is Mia's price. So that's what she paid for it. But who did she get it from? Well, she got it from Jerry. So when Jerry sold the house to Mia, He must have sold it to her for £180,000. So therefore, 180,000 that's what Jerry sold it for. So we're getting closer to what we need to work out. But now, Jay made a profit of 20%. So this £180,000 is actually more than what he bought it for. So 100% plus an extra 20% means that £180,000 must be 100 plus an extra 20%. It must be 120% of what Jerry paid. And a similar process to work out 100% of what he paid, in other words, what he actually did pay. So again, get the calculator. So £180,000 divided by 120, that tells us 1,500. So £1,500 is 1% of what he paid. So I did that by dividing by, pardon, my voice is going strange. Did that by divided by 120 on both sides. And finally, multiply by 100 to work out 100%. So therefore, timesing that by 100, I get £150,000 is what Jerry paid. So it's a back to front question. You need to work in reverse of that one. So potentially tricky, but there's a method to it, as you can see. Question 12, we need to interpret a straight line graph. So we've got this graph showing the volume of liquid, L litres, in a container at time t seconds. First we need to find the gradient of the graph. Well, we need to remember that the gradient is just defined as the change in y, or whatever is going up, divided by the change going across between any 2 points we are able to pick. So pick 2 nice points. I'm going to pick that one and this one. So between these 2 points, the change in y is going to be from here up to there, and the change in x is going to be from that point across there. So thinking about y first, it ends up at 16, used to be at 4. And x ends up at 8, used to be 0. So the change in y, it's gone 12 litres up, and it's gone 8 seconds across. So 12 over 8 is 1.5. In fact, I'll just put this down here actually. You'll see why in just a moment. So the gradient of the graph is that. Now B, it says explain what the gradient represents. Well, it represents the rate of which the container is filling with liquid. So the gradient is a change in the y-axis, it's litres, divided by seconds. It's the rate of how many litres are being added per second to this container. And C, the intercept when the time is 0 is 4 litres. So that means when we start the stopwatch or whatever, there was already 4 litres of liquid in this container. So explain what this means. Quite simply, all it means is it's the amount of liquid that was in the container to start with. Okay, so that was the amount of liquid in there before we even started filling it up from a tap or hose, whatever it might be. Question 13, we've got two similar solid shapes. Surface area of A to the surface area of B is 3.4. We're told the volume of shape B. We need to work out the volume of shape A, giving answers to three significant figures. The key word here is these two shapes are similar. So if they're mathematically similar, we need to remember and know some important thing. So what we need to bear in mind, if two shapes, call them A and B, because these are, if they're mathematically similar, then let the ratio of their lengths be A dot dot B. Then what we'd have is the ratio of their areas is A squared to B squared, and the ratio of their volumes is A cubed to B cubed. Now I don't know why, I've got a comma there, it's annoying me, so there, I can go. So always try and work out the length ratio first. What we're told here is the area ratio. So area ratio of A to B is 3.4. To go from something squared to something not squared, to undo the squaring, we need to square root. So if I square root these numbers here, then the length ratio would be the square root of 3, which is root 3, to the square root of 4, which is 2. So the length ratio of A and B is this, given that the area ratio was 3 to 4. Now, to go from A to A cubed, or from B to B cubed, we need to cube both numbers. So the volume ratio, root 3 cubed, let's work that one out. So root 3 equals, press cube, 3 root 3, and 2 cubed is 8. So the volume ratio of these two is 3 root 3 to 8. Now we're told what the volume of shape B is. The volume of shape B is 10 cm cubed. So those 8 parts for A, remember this is A then B, those 8 parts must be worth 10 cm cubed. So what do we need to multiply 8 by to get to 10? Well, I can do that by doing the big number divided by the smaller. So 10 divided by 8 is 1.25, so I multiplied by 1.25. If I do it to the 8, I can work out the volume of A is by again multiplying that by 1.25. So 3 root 3 multiplied by 1.25 gives me 15 root 3 over 4, so 6.495 and so on. One colour, 6.495. However, we want the volume of shape A to three significant figures. So we've got the volume here. I want it to three significant figures. So therefore, the volume of A, correct to the appropriate degree of accuracy, 1, 2, 3 significant figures. So 6.49, but next to that 9 is a 5, so that 9 rounds up. So the 49 changes to a 50. So it's 6.50 cm cubed. Don't just put 6.5, that would be 2 significant figures. We need 1, 2, 3 digits if it's 3 significant figures. And that's question 13 for you. Question 14 is a 2-marker, and it's quite straightforward if you just see it or you're good at these sort of puzzles. And it's really hard and, dare I say, in my humble opinion, unfair if you can't quite see what to do, because it'll take much longer than the 2 minutes for 2 marks, which I'd normally recommend. So I'm going to go off the idea that this isn't going to be obvious to you. So if you're out there thinking, well, there's an easier way of doing it, then fair play. There's a formula, but I'm going to go off a premise that you see this question and you're just thinking, what on earth do I do? So I'm going to base it and build it up from scratch. There's 16 hockey teams in a league. Each team played 2 matches against each of the other teams. Work out the total number of matches played. So let's build up this understanding from the bottom up. So building it up, let's just think about 16 teams might be too much to get your head around. Let's think of the smallest number of teams. Let's think of, to start off with, just if you had 2 teams. Now they played 2 matches against each other. Think of it as 1 pair of matches. So if 2 teams in a league, obviously they can only play each other. So that'd be 1 pair of games they'd play. They play each other twice, which is 1 pair of games. So the 1 pairing and represented by this red line. So 2 teams would be 1 pair of matches. Let's build up to 3 teams. If you had 3 teams, 1, 2 and 3, for the first team has to play the middle team and the end team, so that's 2 pairs of matches. That middle team's already played the first team, so it needs to play the end team. So it's 1, 2, plus 1, if you notice. 2 plus 1 is 3 pairs of matches. What if there are 4 teams? Now, if you ever watch the World Cup, I think might be the same for rugby as well, I'm not sure, but the World Cup in football, there's 4 teams in each group stage. And you might well know that they play each other the total of the times in the group stage, the teams play 6 times. So if you have 4 teams in a group stage, the first team plays the other 3, 1, 2, 3. Then that second team's already played the first team, so that team has to play 3 and 4, so 3 plus this other 2. And finally, there's another one along the top as well. So in total, that's going to be 6 pairs of matches. What if there were more though? What about 5 teams? So again, a harder diagram to construct, and at this point I want you to sort of see if you can maybe spot a pattern that's going on here. Well, 5 teams, if you did think it through. First team has to play the other 4. That one plays another 3. Then that one has to play another 2. Then 1. By the time you get to this one, all of your ones have played it, so that one's done. So this would actually be a total of 10 pairs of matches. So if you can't see the pattern yet, it's going to be really hard for you to get your head around the question. These numbers here are triangle numbers. 1 is obviously 1, 3 is 1 plus 2, 6 is 1 plus 2 plus 3, and 10 is 1 plus 2 plus 3 plus 4. So for example, if you had 6 teams, we've gone up by 2 there, increased by 3, increased by 4, here I'll increase by 5, that's going to give me 15 pairs of matches. So what I can do here is I can build this up in a table. Now, this would be the question, if you don't get it straight away, it'd be one to return to at the end of the exam when you've tried everything else. I think this question's a bit mean personally, but that's just me. So, like we said, 1 team can't be done. 2 teams was 1 pair of matches, then 3, then 6, then 10. So what we're doing each time is we're adding an extra number on. So what we're going to do here, I'll just show you what's going on. We start with 1, then plus 2 to get to the total if it were 3 teams. Plus 3 gives us 6, that's if it's 4 teams. So the final number we're adding will tell us the total pairs of matches for when we have that number of teams plus 1. For example, their number is 3, that'll tell us a total of 4 matches. So we need to keep going until we get to 15, because 15 plus 1 will tell us for 16th. So keep adding up as we go, carefully. 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. That gives you 120. Doing it the very long way, it'd be adding them up like this. That'd be 15, and plus 6 would be 21, plus 7, 28, plus 8 is 36, plus 9, 45, plus 10, 55, plus 11, 66, plus 12 is 78, plus 13 would give you 91, plus 14 give 105, plus 15 is 120. So it's 120 pairs of matches, not matches in total. 120 pairs, which equals 240 matches in total. Me, personally, not a fan of that question, not for GCSE anyway. If it were an A-level one, I could forgive it. Let's have a look now at the next question, number 15. We've got the graph showing the speed of the car in meters per second during the first 20 seconds of a journey. We need to work out an estimate for the distance the car travelled in the first 20 seconds. Use 4 strips of equal width. Well, the total journey goes on for 20 seconds. If we're using 4 strips, those 4 strips must total 20 seconds. So each strip must be 20 divided by 4. It must be 5 seconds wide. So what we can do here is add strips in, 5 seconds wide, going from the bottom to the top of a curve like so. 5, 10, 15, 20. Now what we need to do here is we construct trapeziums, or to be fancy, trapezia, from these strips. So we draw straight lines from the top of one line to the beginning of the to the end of the next line. So we draw straight lines joining them, and this one here, we do a straight line from 5 down to the origin. So we construct the trapeziums like this. We therefore have 4 trapezia, which I'll colour in, like so, just so it's clear. The first one, in my mind, is actually a triangle. Think of it as a triangle, or a special case of a trapezium, it doesn't matter. In my mind, that's definitely a triangle. So I'll explain how we calculate these areas. As long as you can remember what the area of a trapezium is, you're good to go. And if not, well, it's here for you. So first of all, what we need to do is label on, if we can, the heights of each of these lines. So that one comes up to 22, that comes to 28, this height's 32, this one's 35. So we're going to use those in our calculations. And like I say, the formula for trapezium, I will put it here for you. So here it is. So for any trapezium, it's half of the one side plus the other parallel side multiplied by the height. And because these trapeziums on their side, that's going to be multiplied by the width. So let's go now and do this step by step. So the total area, I'll do this triangle first. So area of a triangle is half times the base, it's 5, times by the height, it comes up to 22. So that's the height of the first one, that's the triangle height. Next, this one definitely is a trapezium. So what I need to do here is use this formula. So this one's going to be half. This parallel side here is 22, and that one's 28. So it's half of 22 plus 28, multiplied by the width. Now the width in each case is going to be 5. So that's the area for the green one. And keep going. Next one, half of, well, for the blue, that first side comes up to 28 and that one comes up to 32. So it's half of 28 plus 32. Again, times 5. And finally, for the biggest one, it's half of this side, which is 32, plus that side, which is 35. Times by the width again, which of course is 5. So now we just process this on the calculator, taking absolute care, because it's quite a lot to be punching in. So first of all, we've got a half times 5 times 22. Then if you want to put brackets in where you can, but remember BIDMAS, it'll multiply first and then add them up separately anyway after, because multiply comes before addition. So the calculator will sort that for you. So then I've got plus half of 22 plus 28 times 5. Next we've got plus another half of something, so this time it's half of 28 plus 32. Again multiplied by the width of 5. And finally, for the purple one, it's half of 32 plus 35 multiplied by 5. You get 999 over 2, so you can leave that as a top of a fraction, or you can convert it into a decimal and get 497.5. I'm timesing meters per second by second, so it's going to be 497.5 meters. Finally, from physics or maths, hopefully both, you need to know that the exact area under a speed time graph tells us the distance travelled. This here is an estimate. These trapeziums added together give us a fairly good idea of the total area underneath this graph. But if you can see here, these trapeziums altogether will be an underestimate because I've still got some bits missing. So there's that bit there that hasn't been included, and that bit there. So essentially, because these trapeziums, the top sides of them, are always slightly underneath the curve, this area here is a slight underestimate of this whole area, because the actual area under the curve is these coloured in bits plus these bits here have missed off. So it's a tiny underestimate, so we need to put that into words for this one. Is it an underestimate or an overestimate? So what we need to say is something along these lines. It's an underestimate because the top sides of the trapezia are all below the curve. Question 16. The nth term of a sequence is given by an squared plus bn, where a and b are integers. The second term of a sequence is -2, and we're told that the fourth term is 12. We next need to find the sixth term of this sequence. So for this one, the process is just substituting in what we need. So we're told that the nth term is an squared plus bn, whatever n is. So n could be the first term, the second term, whatever it needs. So we're told here the second term is -2. So if we sub in n equals 2. So the second term is -2. So when n is 2, the nth term is -2. In other words, a times 2 squared plus b times 2 equals -2. In other words, 2 squared is 4. Stupid. 4a plus 2b is -2. Whereas the fourth term is 12, so we can sub in when n is 4. So when n is 4, an squared would be a times 4 squared. bn means b times 4. And that'll tell what the fourth term is, which is 12. So therefore a times 4 squared, which is 16a, plus b times 4, which is 4b, that equals 12. So I've now generated two equations which I can now solve simultaneously. So I've got 4a plus 2b equals minus 2. I've also got 16a plus 4b equals 12. So what I'm going to do here, I'm going to put them next to each other in any order, and I'm going to think about solving them. I'm going to put this blue one here at the top. So I'm going to put that here, 16a plus 4b equals 12. Now you need to remember, to solve simultaneous equations, what we're needing is the numbers in front of one of the letters to be the same. So here 16a isn't the same as 4a, that 4 isn't the same as the 2. But what I could do, I could multiply everything in this green one by 2. Just double the whole thing. So if I doubled the whole thing, 4a would become 8a, 2b becomes 4b, minus 2 becomes minus 4. So now I'm good to solve these simultaneously. Next what I'd suggest we do, is we look at the thing which has the same number in front and look at the sign. So of the things that are the same, both symbols are positive. And I always tend to say, when the signs are the same, we subtract. So the signs of numbers which are the same are actually the same signs, they're both plus. So what we're going to do is the top equation subtract the bottom. So 16a take away 8a gives 8a, 4b take 4b cancels, 12 minus 4 is 16. Check it on your calculator if you have any doubt or you think you might make a mistake with negatives. So that's what your calculator's for, use it to your advantage. But anyhow, 8a is 16, so therefore a equals 2. I can now substitute this into one of the original equations. So now what I can do is sub a equals 2 into one of the starting equations. I could pick this one here, into 4a plus 2b equals minus 2. Doesn't matter which one you pick. So that would become 4a becomes 4 times 2 plus 2b equals minus 2. 4 times 2 is 8, so 8 plus 2b equals minus 2. If I subtract 8 from both sides, swap side, swap sign, 2b will be minus 2, take away another 8, check on a calculator if you don't like negatives, minus 2 minus another 8 will be minus 10. Finally divide by 2, we see that b equals minus 5. So the final step is to actually just put this back in. So we've worked out now what a is. So if this sequence a is 2, and we've also worked out that b is minus 5. So therefore the nth term is an squared, so that's going to be 2n squared, plus bn plus minus 5n, so that's just minus 5n. So therefore the 6th term, we just plug in when n is 6, we're going to get 2 times 6 squared minus 5 times 6. Try it on the calculator, see what we get. So 2 times 6 squared minus 5 times 6, you get 42. Next, we need to work out the nth term of this sequence. Now there's a few ways of doing these. I'll show you the way I tend to use. It's possible your teacher uses a different method. Whichever method makes sense to you. I really don't mind which way you want to think it through. What I would say though, in general, for any general quadratic sequence, the nth term is an squared plus bn plus c. It's essentially a generalization of the quadratic formula, just when n is a whole number instead of x being any real number. So the nth term is an squared plus bn plus c, where a, b and c are the numbers we need to find. So the first term is 0. We just need to pick the first three terms. The second term is 2. The third term is 6. So the first term, there's a pattern to these. If you revise them and you're in my class, you'll know what I'm talking about, I'm hoping. So the first term is when a is 1. So that's a times 1 squared plus b times 1 plus c. The first term will always just be a plus b plus c. If you are given the first term, you almost always are. So 0 equals a plus b plus c. The second term, we can use the same idea. So the second term, just plug in when n is 2. So that's going to be a times 2 squared plus b times 2 plus c. 2 squared is 4, so we get 4a plus 2b plus c. So 2 equals 4a plus 2b plus c. And then 6, which is the third term. The third term is going to be a times n squared, which is now 3 squared, plus b times n, which is b times 3, plus c. 3 squared is 9, so that's going to give us 9a. b times 3 means 3b plus c. So these coefficients, if you are given the first three terms, will always be the same. The first term is always a plus b plus c. Second term is always 4a plus 2b plus c. The third term is always 9a plus 3b plus c. So that's where the numbers come from. So what I'll do here is I'll just clear that away for now to give myself more space for tackling this question. So what we can do here is generate different equations from these. So if I just pick on these top two, if I do the middle one, take away the top one, 2 take away 0 gives me 2, 4a take away a gives me 3a, 2b take away b gives me 1b, c take away c cancels. Do the same down here. The bottom equation, take away the middle. 6 take away 2 is 4. 9a take away 4a is 5a. 3b take away 2b leaves me just 1b. And again, the c's cancel. Now we go again. Do the bottom, subtract the top. 4 take away 2 gives us 2. 5a take away 3a gives us 2a. b take away b vanishes. So I can see now that definitely 2 equals 2a. Divide through by 2, therefore a equals 1. So now I'm going to sub a equals 1 into one of these earlier equations. So let's pick this one, for example. It doesn't matter which one you pick, as long as you pick one of the middle ones. So I'm going to sub a equals 1 into 2 equals 3a plus b into this one. So I'm going to get 2 equals 3 times 1 plus b. So 2 equals 3 plus b. So therefore b is 2 minus 3, which is minus 1. Finally, sub A and B into the first equation. So first equation, this one, 0 equals A plus B plus C. So 0 equals A, which is 1, plus B, well B is minus 1, so plus minus 1 is just minus 1, plus whatever C is. Therefore we can see here that C's got to be equal to 0. So the nth term, all we do next for the final step is we plug in what we've got for A, B and C. This is the formula for the nth term, so it's an squared. So A is 1, so I can put 1n squared. B was minus 1, so minus 1n plus nothing, which we need to neaten up, but that's where the numbers come from. 1n squared is just n squared, minus 1n is just minus n. So this nth term here is simply n squared minus n. For number 17, we have to work out the length of AD, giving answers correct to 3 significant figures. So, we can see these are triangles joined together, but they certainly aren't right-angled triangles, so we can't use standard trigonometry or Pythagoras. So, if it's not a normal trigonometry question, chances are it needs to be either the sine rule, the cosine rule, or maybe even both. So just to remind you, you need to know these, ideally. Depending on where you are and when you're doing the exam, it might be that you're given these formulae because of COVID or whatever other reason. If you're watching in a few years later, who knows, you might be given these or not. So in any case, it can't hurt to know these anyway, off by heart, and at the very least just get used to how to apply them for your exam. So the side I want to find is AD. So let's see if we can find out straight away. So AD is this one. But as you can see, I don't really know much information about this triangle. I know that's 11.4 and that's 86, but I don't know enough to work out AD. So let's go to this triangle where I know more about it. So I know an angle, an opposite side pair, and another piece of information. This is a clue that I can use the sine rule for the bottom triangle. So what I can do here is I can use a sine rule for this triangle BCD. Now, ultimately I'm more interested in this top triangle than the bottom one. So I could do a finding out this side, because this side at least will relate to the top triangle, which I'm trying to get to, in a sense. So let's see if I can work out this one here, which is the side DB. I'll just label that DB. Now, the sine rule, small letters stand for sides, big letters stand for angles. So this DB, I'm going to think of this as being A, okay, because I want to work this one out. So if I just move this to the side a second and call this A, then the side opposite to, the angle opposite to side A is angle A. So this here will be angle A. So angle B and side B can be whatever I want them to be. So I can call this one B and that angle B for now. And we can apply this bit of the formula. I want to work out a side, so start with the side I'm trying to find first. So start by writing down A. So A, which is really DB, so A divided by sine of the angle opposite to it, so A divided by sine 34, that must equal side B, which we labelled as 12.5, divided by sine of the angle opposite to it, which is 109. So I can now work out what this is if I want to. So if I just calculate 12.5 divided by sine 109, let's see what I get. So sine 109, 13.222, or 2202. Therefore, I can now multiply both sides by sine 34 to get what A is on its own. So A equals sine 34 times by 13.222. Keep saying 222, it's 2202, and so on and so on. So essentially, the answer you just got on your calculator. Keep that stored as so. That's what this thing in green was. Then I'm going to multiply that by sine 34. You should find that you get 7.392-ish. So don't round it yet, just write down all the numbers on your calculator display if necessary. So we've got 7.392. What else did I have? 6747. 4, 4. So that's side A worked out. So A is that. Essentially now I've got A, I can forget for all intents and purposes that other triangle and just fill in what A actually is. So A, side DB, is 7.392. I'm not rounding yet, so I don't get any rounding errors. 674744. Okay, and the rest of this triangle now doesn't matter, so I'm taking it in two separate steps. So first step I've got A. Now I can essentially forget what I've just done, because now I'm just interested in this top triangle and that top triangle only. So I couldn't really care less anymore about that other triangle. It was just a means to an end. Now I can focus on this top one. And now I can relabel if I want. So I'm trying to find AD. Okay, so I'm trying to find a side. I'd always suggest labeling the side you want to find, if you can, as side A. I know you're probably thinking, well, I did A before, but forget that now. Scrap it. We've got what we need from that part of the question. Let's relabel. So that's A. Opposite to that is angle big A. Now, if I'm trying to find a side, and I know two other sides and the angle in between, that's a case where I can use a cosine rule. So I've got A. I'm trying to work out little a. B and C in any order are 11.4 and 7.39 and so on. So I'm going to call B this 7.391, and I can call the C 11.4. So cosine rule, next, for the triangle ABD. So AD, which is a side A, in fact I'll put that in red just so it's clear what I'm talking about. So AD, this tells us what A squared is. So A on its own is a square root of this whole thing. It's a big square root as well. So it's going to be the square root of side B all squared. So this 7.39, so on and so on, all squared. Plus side C squared, so plus 11.4 squared. Then minus 2 times B, this 7.3926 business, times by C, which is this 11.4, times by cos of angle A, which is 86. So I just carefully put this into my calculator, just taking my time throughout. So, by the way, if you check as well, the answer you should have stored what that side was from before. So you should have 7.3926 in exact form. So just leave it by pressing ANS. So it's the square root of this number here, squared, which is ANS squared, plus the 11.4 squared, minus 2 times that 7.39, which is stored as my answer, multiplied by 11.4, multiplied by cosine 86. Close brackets, plus equals, and we get to three significant figures, 13.1 centimetre. First, second, third significant figure. The 4 doesn't make the 1 round up, it stays as 13.1 cm. And so that's that question done. Question 18. Show that the equation x cubed plus x equals 7 has a solution between 1 and 2. Well, what we do here is we sub in when x is 1 and when x is 2. So when x is 1, x cubed plus x equals 1 cubed plus 1, which is 4, which is obviously less than 7. But when x is 2, x cubed plus x is going to be 2 cubed plus 2, which is 10, and that's now more than 7. So it's gone from being less than 7 to more than 7 in between 1 and 2. So it must have overtaken and been equal to 7 at some point in between 1 and 2. So imagine this as a graph, if you like. Now, this graph I'm going to show you is just for understanding. You don't need to do it for the examiner's sake. I just want to try and show you why this is the case, what's going on. So I want you to imagine the curve of y equals x cubed plus x, like so. So imagine it in blue. It's a cubic, so it's going to go big as x goes big. So we've tried it when x equals 1. When x is 1, x cubed plus x is 4. And when x is 2, it comes out to being 10. So it'll be equal to 7 when the height of the line is at 7. So if I imagine a line here going across where y is equal to 7, then x cubed plus x will be equal to 7 where these lines cross over. And because it's equal to 4 when x is 1 and equal to 10 when x is 2, that stands to reason, but it's got to be equal to 7 somewhere in between when x is 1 and when x is 2. So in terms of wording it for the exam, you might want to put something like this. From x equals 1 up to x equals 2, x cubed plus x goes from below 7 to above 7. So x cubed plus x must be equal 7 between x equals 1 and x equals 2. Part B, we need to show that the equation x cubed plus x equals 7 can be rearranged to give x equals a cube root of 7 minus x. So first of all, let's just start with the equation as given. So if we now rearrange it to have x cubed on its own, for example, we can subtract x from both sides. In other words, I sometimes think of it as swapping side, swapping sign. So we then get that x cubed equals 7 minus x. Then if we cube root both sides, because we can undo x cubed by doing the opposite of cubing something, the inverse of cubing is cube root. So from here, we therefore get that x must be the cube root of 7 minus x, like so. Next, we have what's called an iteration formula to do. An iteration formula just means we plug a value in again and again and again. We use this formula 3 times to find an estimate for the solution of x cubed plus x equals 7. So we're told that x0 equals 2. So the first iteration, xn plus 1 will be x0 plus 1, which will be x subscript 1. That's going to be the cube root of 7 minus x to the 0, which is 2. Oops, wrong colour. It can be cube root of 7 minus 2. Let's see what that gives us. So if we do shift, then this power button, but we type in 3, in fact you could use this button as well, I suppose, then 7 subtract 2, that gives us 1.709975 and so on and so on. 1.709975 947. So we've just worked out what x1 is. We need to do this 3 times. So the second iteration, we're going to find what x2 is. So x2 is going to be the cube root of 7 minus x1, which is what we just had here. So 1.7099, I'll just put dot dot dot. So the examiner knows I'm using the exact value, not rounding it. Again, don't worry about mistyping on your calculator. Okay, your calculator's got this answer stored. So what you can do next, because that's your answer stored, you can just press Shift, that to get your cube root, then just press 7 minus my previous answer. So the next one is going to be 1.7424. Write down all the numbers if you can. 18802. So that's the second one. And then the third one, the last time we have to do it would be to find x cubed. So x subscript 3, I mean to say. That's going to be the cube root of 7 minus 1.74241, etc., etc., etc. So again, we can just use the previous answer stored to save some time. So Shift, square root button, 7 minus my previous answer, 1.7388. And put a few more numbers on, why not? 49506. So that's x cubed. So the estimate is over x equals, if you look at these two values here, they're getting closer. They're actually becoming 1.74. They both agree to 2 different figures. So if you want to round it to, sorry, 2 decimal places, if you want to round to 3 decimal places for your estimate, that would be fine. This to 3 decimal places, sorry, 3 significant figures would be 1.74, because of it next to the 3 pushes the 3 up to a 4. So x equals 1.74, correct to 3 significant figures. Question 19 now. You've got 2 right-angled triangles, and we're told that the tan of E equals a tan of F. And what we need to do here, whoops, making lots of mess, what we need to do is just work out the value of x. So work out the value of x, and we need to show all working. So it looks like a trigonometry question, and in a very loose way it is, but we're not really going to do much trig at all. So the first thing we need to think about is obviously SOHCAHTOA, as follows. And then what we could do here is just be thinking what tan actually is. So tan equals O over A. Okay, so tan for this one equals O over A. Opposite divide by the adjacent. So the opposite side is x, the adjacent side is 4x minus 1. And so for this one here, tan e equals x divided by 4x minus 1. Now this one, for tan f, again is opposite divided by adjacent, but in this case the opposite side here is 6x plus 5, and the adjacent is 12x plus 31. So tan f is this. Now we're told that tan e equals tan f, so therefore what we can say is x over 4x minus 1 has to equal 6x plus 5 all over 12x plus 31, just making one side equal to the other. Now we've got one fraction equals another. Think about when you simplify a fraction. So just a bit of a thought experiment. Let's say, for example, you want to simplify 5 out of 10. Well, 5 over 10 is the same as a half. But just check what happens if you multiply each number by the opposite corner. 1 times 10 is 10. 5 times 2 is 10. Each corner multiplied by the opposite corner is equal to the product of when you multiply the other two corners together. So what we can do is can say x multiplied by 12x plus 31 will be the same as 4x minus 1 multiplied by 6x plus 5. So this here was simply just to illustrate what's going on. So I can get rid of that for now, but that's actually what's happening. So if I just clear this off the screen, because I don't need that now. So what we'll do is cross multiply these. So we've got x times 12x plus 31 equals 4x minus 1 times 6x plus 5. Now the first bit we can expand out quite simply. So x times 12x is 12x squared. X times 31 is 31x. But this here we need to expand to brackets. So what I'm going to suggest we do is we do it in this box method. So we've got 4x minus 1 multiplied by 6x plus 5, which I just need to correct that. That should be a plus 5. There's other methods. There's FOIL, for example, for multiplying out two brackets, but I prefer this method, so I'm just going to do this here. So 4 times 6 is 24. X times x is x squared. That's the first box. This box is 6x multiplied by minus 1. That gives us minus 6x. Down here, I've got 4x times 5, which is 20x. And the final box, 5 times minus 1, gives us minus 5. So if I simplify this down, I've got 24x squared. 20x, if I then take away 6x's, that's going to leave me with 14x overall. And of course, minus 5. So this whole thing here, I can replace with 24x squared plus 14x minus 5. I can then get everything onto the same side of the equation. So if I were to subtract 12x squared from both sides, I then get 31x on its own. So 24x squared take away 12x squared gives 12x squared plus 14x minus 5. Finally, if I take away 31x from both sides, I'll end up with just 12x squared. 14 take away 31, check on a calculator, is minus 17x minus 5 equals 0. So that now is in a standard quadratic form, which can now solve either by factorising, if it will factorise. It turns out it will, but what I'd suggest is, if it's a calculator paper, you might want to use the quadratic formula, which you might well find much easier. So using this, I can now use this quadratic formula to solve it. So we just need to input our corresponding values of what A, B and C are. So A is just the number at the front of the x squared, if there is one. That's a 12. If it just said x squared, the number would have been 1. B is the number in front of the x term, which is just minus 17. And finally, C is the number on its own, which is minus 5. So that's how we work it out. So it's just a case of typing it into the calculator carefully. So therefore I can say x is going to be plus or minus, I'll do the fraction line first. Apologies, it's minus b first, I'm not with it today. So minus b is going to be minus 17, which is plus 17. Then plus or minus the square root of b squared, so minus 17 all squared, minus 4 times a, which is 12, times c, which is minus 5, all of that divided by 2 lots of 12. So if we try this, so 17, let's try the plus option first. So plus the square root of minus 17 squared minus 4 times 12 times minus 5, all of that divided by 2 times 12, I get 5/3. Let's try it when it's a minus, because it's plus or minus this formula. So just toggle back, carefully delete the plus, change to a minus, and get minus a quarter. So x equals 5/3 or minus a quarter. But just think about it. Think about what x is. X relates to lengths. This triangle here has an opposite side of x. Could the side of a triangle really have a length of minus a quarter of a unit? It can't. So what I need to do here is just think, actually, that answer must be a nonsense. Therefore, the only answer I've got is that x must be 5/3. So as long as you take care, you'll still be fine, and that's question complete. Question 20 is the penultimate question. This one, then just one more to go. So 50 people are asked if they speak French or German or Spanish. Of these people, 31 speak French, 2 speak French, German and Spanish, 4 speak French and Spanish but not German, 7 speak German and Spanish, 8 do not speak any of the languages. All 10 people who speak German speak at least one other language, and 2 of the 50 people are then chosen at random. Find the probability that they both only speak Spanish. So it might be tempting here to think about this as a two-way table, but a two-way table is only useful if the events are mutually exclusive, if it's either one thing or the other. So for example, if it was either French or German or Spanish with no overlap, a two-way table would do it. But here, because there's clearly some overlap between studying French, German, Spanish, or some combinations, what we need here is a Venn diagram, carefully constructed. So 3 different circles with overlapping sections for each possible scenario. So what I'd suggest we do is construct it first by drawing out a rectangle in the space in your exam paper. Then 3 circles which each overlap each other and have a region where all 3 overlap together, something like this. Now what we need to do is label each of these circles French, then one for German and one for Spanish. Now we can start populating the information we've been given. So first of all, what we need to do is we start with the overlaps first. That's absolutely crucial. And we start with the biggest of the overlaps first if possible. So what I'm going to try to do what you always need to do is start with the one where they all overlap together. So do this one in the middle first if we can. So as I'm colouring in like a child, I don't think you're ever too old for colouring in. You read the question and you be thinking, well, what number would go in this middle bit? What number represents the people that study both French and German and Spanish? Does it say? Well, yes, it does. It says 2 people speak all 3. So what we do is we put 2 people in there. Next, what other overlapping bits do we have? Well, we're told that we have 4 people that speak French and Spanish, but not German. So if they're speaking French and Spanish but not German, that means it's where the French and Spanish circles overlap. So they overlap here, but they're not speaking German, these people. So the bit of the French and Spanish circles that overlap that excludes German is just this section of it here. And so this is where we need to put 4 people in. So this bit I'm colouring in green, we just pop 4 people in that one. Maybe should have called these in first, I don't know, but bear with me. So that should be 4 people. Next it says 7 people speak German and Spanish. So if they're speaking German and Spanish, they need to live in the place where the German and Spanish circles both overlap. So that's going to be this region here, where the German and Spanish circles overlap, is this region here. So this needs to total 7 people. So far we've got 2, so this other sub-region must be the other 5 people. Now 8 people don't speak any of the languages, so I need to put 8 not belonging to any of the circles. So 8 just goes on the outside of the Venn diagram. It now says that all 10 people who speak German speak at least one other language. So in other words, you can put optionally, there's no people that only speak German. So the 10 people who do speak German speak at least one other language. So we've got 5 people that speak German and Spanish too. There's 2 people that speak German and the other 2 languages, French and Spanish combined. So the other 3 of these 10 here must speak German and French. 3 plus 2 plus 5 gives us 10 people in total in the German plus at least something other overlap. 3 plus 2 plus 5 gives us 10, which is what we actually do need. So there's still a bit more to fill in. So now we've done over the overlapping bits, we can return and start thinking about the earlier bits too. So what we had here from before is that there were 31 people speaking French. So in other words, the total of people in the French circle, which I'm just going over in this very thick purple colour, the total of all these numbers needs to add up to 31. So I've got 3, 2 and 4 here so far, so I need to just do 31, subtract the 3, subtract the 2, subtract the 4, so minus 3, minus 2, minus 4, must be 22 people that study French on its own. Oops, don't want that colour anymore. So the only one we need to find now, the region, is how many people speak Spanish on its own. Well, now we need to remember there's 50 people in total. All the other regions have been accounted for. So the rest of these 50 people must go in this Spanish circle. So I just do 50, subtract all of these numbers here. Alternatively, I could add all these numbers up and then do that subtract from 50, but either or doesn't particularly matter as long as you're comfortable whichever method you're going for. So for this one here, I'm going to type 50 first, minus of 22 just speaking French, minus the 4 people there that do French and Spanish, minus the 2 clever people that can do any language they want, lucky them. -3, -0, -5, and don't forget this 8, because there's 8 people as well that just don't speak any of these languages. So -v8, 2, gives us a total of 6. So therefore 6 people just speak Spanish on its own. We've now got enough to tackle this question. So the actual question is work out the probability that both the people chosen at random speak Spanish. So the probability that they both speak Spanish equals the probability first person speaks Spanish and then the second person picked would also need to speak Spanish. Now, why am I writing and then? It's because I do think there's a point worth making about the language. So if probability can be phrased in terms of one thing and then the other, it will imply we multiply the probabilities together. So it's a probability of first person being chosen to speak Spanish multiplied by the probability that the second person speaks Spanish. So I should say Spanish only, just to make it perfectly clear. So if one person's picked at random, there's out of 50 people to choose from, the chance that the first person speaks Spanish only is 6 out of 50. And then we pick another person. There were 50 people to choose from to begin with, but we've just picked one of those people, so still now one less people to choose from. There's only 49 other people now to choose from. One person of these 6 has already been chosen. That leaves here only 5 remaining. So 6 out of 50, then the first person disappears, leaving only another 5 Spanish-only speakers out of 49 people in total. So this is the fraction we need to calculate. So we do 6 over 50 multiplied by 5 over 49, and we get 3 over 245. So that's what we write down, and that's the answer to that one. Not straightforward. Final question of the paper now. Question 21. Before I begin, I will say, when I was thinking of how to word this clearly, I began to hate this question. Hate it with a passion. It's absolutely brutal. I'm never really a shapey sort of person. I was never a natural with shapes. I think it shows up even now as a teacher. So I'll do my best to explain this step by step by step. This question I thought was evil. Okay, if you get any of this, then fair play to you. I thought this was really, really hard. We've got ABCD, which is a parallelogram. ABC and QDC are straight lines. Angle ADP is the same as angle CBQ, which is 90 degrees. So these have been labelled on. We need to prove that ADP is congruent, which means they're exactly the same size and exactly the same shape to triangle CBQ. So I'm going to run this through with you step by step as clear as I can, and I apologise if it still sounds gobbledygook. So let's go forward. So we're told ABCD is a parallelogram. So let's just look at ABCD first. Okay, it's this shape highlighted in red. What do we remember from earlier on in your GCSE about properties of parallelograms? Okay, the two main things you need to remember: the opposite sides have equal length, and the opposite angles are the same size. So we can add on the opposite angles and call them whatever we want. Like I'm saying, the opposite angles are equal, so I'm going to colour code these and call them X and Y. So if I call these opposite corners X and the other ones Y, that'll do for now. So then I can make a point to the examiner. Because the opposite angles of a parallelogram are equal, I know this angle from B to C to Q, which I've called called X rather, from B to C to Q as X, is the same as angle from D to A to P. So this X is equal to that X. Also that one's equal to that one, but the key thing that's going to help us here are these angles I've labelled X. So I'm just going to say goodbye to that parallelogram for a moment. We'll come back to it later. Now I want to focus in on these triangles, ADP and CBQ. So I'm going to go over one of these in a red highlighter now. Blue rather, my mistake, can't remember what I'm called. So in blue, I've highlighted it ADP. So if I just move this down here and give myself some more space to annotate over it, this is what I know for ADP currently. I know that that's angle X. So what else can we work out about ADP? Let's also have a look at the other one, triangle CBQ. So say goodbye to ADP here. I'm going to highlight CBQ. And like I've done before, I'm going to move that down here so I've got some space to compare and contrast these two triangles. So I've deduced that they share an angle in common. What else can we work out from the question? Well, look here about the angles. We were told angle ADP equals angle CBQ, which is 90 degrees. So ADP, that's a right angle, and CBQ, this one is a right angle as well. So I can label those on too. So I now know there's two angles which are the same, but that's not enough to prove that the two triangles are congruent. I need an extra piece of information. Next though, if I remember that AD and BC were opposite sides of this parallelogram, and remembering that the opposite sides of a parallelogram are of equal length, this is my way into cracking part A. So if I just highlight AD and BC next, again just saying goodbye to that, and I'll bring AD and BC up here. These two lines in purple, this one's AD, this one's BC, they'll have to be equal lengths. So I say to the examiner, AD equals BC. Why? Well, Mr. Examiner, or Mrs. Examiner, or Mrs. Examiner, that's because opposite sides of a parallelogram are equal. So I can call AD and BC some letter to denote they're the same. I've used X for the angle and Y for the other angle. Let's just call AD and BC Z, for example. So I can label Z on these triangles here, which I've drawn separately. Now, I've got it as long as you remember the rules for congruency. If I've got an angle, then a side, and an angle, in that order, which is the same in both triangles, A, S, A, that proves that the two triangles must be congruent to each other. I've got X, which is an angle, side Z, then right angle there, X, Z, right angle. Over here, I've got X, Z, right angle. So if I state that, that's a solid enough proof that APD is congruent to CBQ. So if I put something along these words, therefore, because ADP and CBQ share identical angle side angle, in brackets that's angle X, side Z, and 90 degrees, they are therefore congruent. Whew, that really wasn't straightforward, I don't think. Part B is marginally more straightforward, but I still don't like Part B either. Part B, explain why AQ is parallel to PC. So I'm just going to clear this off now to give myself more space to just re-tackle the diagram afresh. So I'll just let that fade into oblivion. So first of all, what can we start off with? Well, looking at AP and from Q to C, these lines are clearly parallel. It says on the diagram, in fact. And more than that, we can say that AP is the same length and parallel to QC, because AP is a hypotenuse of triangle ADP, and QC is a hypotenuse of triangle CBQ. And from part A, we proved they were congruent, so we know that they're the same lengths. So that's the start. Next, going back to what I labelled earlier, these two angles are the same. These are opposite angles of a parallelogram ABCD. Angles on a straight line add up to 180. So if I label these Y, then the angles I've highlighted in purple on the other side will be 180 minus Y. So I've just put there angle ADQ must be the same as angle CBP. As well, AD is the same as BC because they're opposite sides of the same parallelogram. So AB and BC are the same. Call them Z, for example. Next, I can say that AB is the same as DC. AB here is the top end of the triangle ABCD, and DC is the bottom side of triangle ABCD. So if we just state that I know the opposite sides of a parallelogram are equal, that justifies that result. Also as well, we said at the very first step, from A to P, the whole length is the same as from Q to C. So if a section at the top is the same as that section, and the whole length is the same, then the shorter bits, BP and QD, must also be equal. So if I add those on in a green colour, what I want to focus in on now are these little triangles at the side. This one AQD and this one BPC. We're going to prove now that these two triangles are congruent. We've both got a side Z, both got the same angle, and both got the same green side. So using the idea of side, angle, side, that also proves congruency. So we state that. So by SAS, test for congruency, triangles AQD and BPC are congruent. Now we're almost done. Because they're congruent, we know all the sides are the same and all the angles are the same. The particular angle I want to focus on being the same is this one here at Q and this one here up at P. Like so. So angle Q is making the same angle with the horizontal as what angle P is. So therefore, they've got to be parallel, AD and PC. Another way I can think of this as well is in terms of Z angles, in terms of alternate angles. If this one here in pink is at Q, then this one up here will also be the same. So that angle I've proven is the same as that one, and that one is the same as that one, so therefore they're going in the same direction. That's overkill, I think, especially for a 2 marker, but I'll just conclude by saying something along those lines. So I think what would suffice is something like this, if I were to just move on and explain why. So if I were to say next, just simply, therefore angle AQD, that one I've done in the pink colour, is the same as angle APC, and so therefore just state that AQ has to be parallel to AC, because like I said, this one here would be a Z angle, alternate angle, which is the same as that one. They're both going in the same direction, therefore a parallel. That I think was a nightmare question, but thank you for sticking with me through that if you did. I hope you found the video useful. Please like and subscribe. Do check out for any other updates. They'll be coming as soon as I get around to doing them. Good luck in your mocks or exams, and take care until next time. For me, it's goodbye for now.